Hi, welcome back to my channel. So today I'll be doing more exam problem sets. So I think these are quite helpful. I remember when I was in undergrad, and to me, I felt like the best way I was successful in taking organic chemistry and being more successful, even in my career field right now as a chemist, was always just like doing more problem sets. So I really want to make sure like you guys pick up on why it's important to do problem sets, work them out, and that's where you can apply the concept that you learned to and a real life problem. And then also when you take an exam, most of the time it's gonna be testing you on problem sets and not concepts. So that's pretty much the reason behind it. So today I felt like we can go through a few problem sets. So let's start with I. So this one is a pretty simple one. This one right here, you can think as it's an SN2 type reaction right here. So in this case, your product that you're gonna see is something like this. Let's move on to J. So you taking this and you treating with LAH. LAH is lithium aluminum hydride. It's a strong base. So what will most likely happen? It's a strong base, but it's also a strong reductant, excuse me. It's just going to reduce the carboxylic acid to this intermediate. And if you don't quench it and then you react it with the alkyl bromide, so this is number 1. And then this would be step number 2. This will now undergo an SN2. And that will lead to your product. So that's J. Let's move on to K. So looking at it, you have ethyl lithium, and then you are quenching that. So, and then you have this in excess. So this is a strong nucleophile that can add here, but at the same time, it can also add at this intermediate. So what you get is a double addition. So that's that. Let's move on to L. So this is a strong base. And this is most likely going to be an E2 mechanism. So what you're probably going to have is this comes to remove this hydrogen, comes here, kick off this, and then you get this intermediate. So let's move on to M. So when you see this is NBS. This is most likely going to do allylic bromination. So this is a 7-member ring. I hate drawing 7-member rings. So you probably get these two mixtures. So let's go to N. So this is magnesium. So you're most likely going to make the Grignard reagent. So this problem is tricky because one would think that you will form this product. You can also form the Grignard product occurring at the other side. So you can also form this one. From here, if you add acetone to it, This will give you these products. So that's the products, the 2 products from N. So let's go down to O. So this will be oxidation, strong oxidation, and this will most likely give you this intermediate right here. All right, let's go down to P. So this is a very strong base. So what will most likely happen? This would depronate this, kick off this. Then you end up forming these, they call them benzene. They're very reactive. And then that it's going to react with your base again. And then you're going to form a carbanion. And then that will get quenched most likely by an intermediate as this. And that's the product. And that should be it. All right. Thank you guys so much for joining. Please don't forget to like, share, and subscribe to this channel. And I'll see you guys in my next video. Bye, y'all.